What's up everybody? So today I've got 3 projects on one piece of material, and here you can see the different colors representing the different layers, which will be recognized by the toolpath as individual operations for later on calculation. Here you can see I've got all these different layers. They're basically per operation, so 90 VCarve, 45 VCarve, and then the central details of the graphic themselves, which will be pocketed with a V profile to bring that out a nice chamfered look. Here's the toolpaths. One thing to note, you can see up top the post processor is a custom one I've made that automatically tells the machine to look for Z height compensation. And then you can see here I've got many finishing passes. Ultimately do one rough and then 1 or 2 finishing passes to make sure I have a nice finish. And as I mentioned before, inside of each of these toolpaths I've got the selection to automatic, and then I'll just calculate it based on what's on the layer that I have selected. Pretty neat feature by VCarve. So right off the bat here, I've got my hardware start and stop buttons down there. Fantastic feature by the EdingCNC board. And I've got some other tool in there. It doesn't matter. I just hit go, and then the machine will say, all right, I'm going to get the tool that's in the toolpath for the first part of the job. So right off the bat, we're going to drill some mount holes so I can attach the material to the spoil board. I'm going to use the holes that it drills right now to secure it for the Keyhole toolpath that I'm going to run so you can hang each piece up on the wall. And then when I flip this piece over, because it's a 2-sided job, those mount holes will line up perfectly because XYZ is in the center, and then I'll be able to use that to hold the material down for machining. So again, we've got our drill installed. We're going to go ahead and hit the button. I had some other operation in between, machine calibration or something. And we're going to go ahead and just hit the drill. I'm doing it really slow. I just haven't taken the time to test these speeds and feeds yet to make sure that I'm as optimal as possible. But for the drilling, it doesn't really matter. So on the back, I run the drills, and then I'll put a couple bolts in just to hold it for the Keyhole toolpath. Here we are. We've got all of my holes strategically laid out not to interfere with the material cutouts. So right off the bat here, I can't do anything with these bolts because it didn't go all the way through. That's because there's a bow in the board this time, and my Z height's not perfect because I don't want to cut through the spoil board. So my solution for that, there's a little bit of material left in the bottom, maybe 1 or 2 millimeters. So I'll just go in there with an 8mm drill bit and slowly carve through the bottom, just because I don't want to go deep into the spoil board or damage any of the metal inserts that are in there for threading. So now I've got that cleared out. We can go ahead and put a couple bolts in, 3 or 4 maybe, just to keep the lateral movement down for the Keyhole toolpath, which is pretty aggressive. So we'll go ahead and set Z0 manually. I'll call it from the hand wheel using a macro that I've adjusted in there in the macro CNC file on Edding. And there it is, 2 probes from the top always to eliminate backlash. Again with that hardware start button, here we go. So we're going to go ahead and swap out the drill, and I'm going to go grab the Keyhole bit, which is a TSlot bit, metric M8. And I found that that's really the best option for these keyholes. Nice large entrance hole, and then the slot is 80mm wide most of the time, unless I have a wider piece. And that makes sure that this is easy for someone to hang up. 1 screw in the wall instead of trying to sit there with a level and get 2 screws correct. That way it's more likely this will get actually hung up and displayed versus end up in a drawer somewhere collecting dust and not being enjoyed. So starting off the toolpath, I've got a pretty conservative but still aggressive 1100mm a minute at 18,000 RPMs, and I go in there, hog out the material, come back. The next thing I do is a finishing pass at twice the feed rate, 2200mm a minute, and that just helps me when I do cleanup to not have to sit there with the vacuum and suck out that channel. So this will put all the chips on the top and make it really easy to vacuum. There's some fuzzies on the edge. I'll come through with a deburring tool real quick and just take those fuzzies off the edge there. Next up, we're going to add some dowels to locate the material on the spoil board. I've got some predetermined holes drilled that are the same for every job. But I'll go ahead and align the material after I flipped it over, put that second dowel in, and she's perfect. XY in the middle, and then Z will be set after this. So I'll go ahead and add all of my bolts in. There's a little bit of a bow in this material, as I mentioned before, and I'll start tightening from the middle out to make sure that the tightening of the flattening of the bow doesn't cause an expansion of the material and push the mounting bolts against each other. Next thing we're going to do is we're going to measure the Z surface and the variations using a 3D finder. Plug that in and run the ZHC macro that's built into Edding that I've modified just a little bit to make it easier. And I do that in the software in the coordinates tab. There's a start measurement option. So I've gone in here and customized a macro to make sure, hey, is your XYZ set for lower left? Yes, it is, because the macro compensation only works from positive coordinates. And then I've made my own dialog here where I specify the length and width of material and just put in how many probe points I want and the clearance distance for the clamps off the edges. Math happens behind the scenes there to make sure I don't have to sit there and measure exactly what my probe distance is. It just says, okay, 6 points, boom, and it goes ahead and measures across the entire length. Once that's finished, I can go ahead and just hit go, and the post processor that I've created asks me if I want to set Z0 using Z height compensation on, because otherwise the measurements will be off. So I'll go ahead and go through a probing process. It'll tell me go ahead and place your probe, and just hit go after I'm done with that. So I go ahead and hit my hardware start button, which is also the OK for dialog boxes, which is another great option they just came out with EdingCNC. And we'll go ahead and set Z0. Once this is done, the software will stop and wait for me to remove the probe and hit OK again, as you can see here. And these are just dialog messages that I've created in EdingCNC macro file. From there, I hit go, it says I've removed the probe, and it'll go ahead and start carving with my first bit. So we've got a 45 VCarve here. I'm very conservative, 1200 millimeters a minute for feed, and I'm working on some really fine lettering, and I want to make sure that I definitely get as deep as I can to make sure you can still see them with the contrast. After the 45 is done, we switch over to the 90 insert. I'm again running 1200 millimeters a minute and 18,000 RPMs for this. My finishing toolpaths with these chamfers and most of my V's will be at 24,000, just to make sure that I get a little bit of a burnish, but moreover that I get rid of all those tiny little fuzzies that end up in the valley of the VCarve. Here's a quick shot what the chamfers look like afterwards, and we're getting started on the VCarve. I've selected a VCarve for some of the smaller details, so I don't have to worry about a pocketing toolpath with the 1.5. So we're running a profile now to cut the chamfer into the detail of the graphic. After that, we'll come in with a 1.5 millimeter end mill, and we'll just run a pocket toolpath for the text. I found that running a 1.5 by itself gives me better results than trying to fit a 6 millimeter into some of these spots and leaving some of the divots from the bottom of the bit because it's not perfectly flat for the cutting. So we've got the 1.5 working pretty hard, and you've got some fuzzies left over from the 90. This will run a profile and clear all those out. After the 1.5 runs, we've got a 6 millimeter running a pocket, and you'll notice there's a little bit of a gap there on the edges. That's because this is running 2 depth passes so that I don't have any tear out on the floor. So the final pass depth of this will be 0.5 millimeters, as you can see here, and then everything will line up just perfectly without any tear out along the grain. I was having a lot of issues with that last little sliver getting knocked off when I ran a full 2 millimeter pass. So this kind of eliminates that, doesn't overload the bit, and the wood stays intact. Once all that's set, we're going to run a profile toolpath around the outside, and I run 3 of these, 2 of them with tabs, and then a final one, kind of a spring pass, but more just to trim the tabs down so I can cut them out easier. And I'm using an air blast here just because I really like the effect that it gives with getting the chips out of the way. It gives me a much nicer edge surface finish instead of having it re-chew chips and then make a little bit of chatter along the way. So we've got them all cut out, and one thing I thought was kind of interesting, the board was so bowed that once the tension was relieved during the cutout, I got some warp, and I ended up eliminating that bottom tab without even realizing it. But just taking a look through here, we can see we've cut all the way through. There's some onion skin in some spots, which is great. It means I haven't cut too deep, but I've cut enough where I can get this material out very easily. And my goal with an automatic measurement macro is to always cut at the same depth, not ever cut into the spoil board, which I've done before and it kind of sucks. It reduces the life of the spoil board. But once I'm done, I go ahead and run a vacuum through here, and then I grab my trusty cherry chisel and I just press down to cut through the tab. I'm not trying to pry it away from the edges of the cut because that would potentially break the tab off into the material, the piece that I want to keep. So I actually go ahead and cut that with a chisel to release this from the stock. And on smaller jobs, I'll actually pull the stock up first and keep the plaque on the board just in case I missed a tab. That'll make sure that it rips out of the stock instead of ripping out of the back of the plaque and making something extra that I have to sand. And here's just an overview. You see some onion skin there, really great sign that my depth of cut is just perfect. And I've got a macro on that I'll expand on in another video. So we're going to move on to hand tools of woodworking, and I'll use a router to flush cut all the tabs off. And then we'll go ahead and move into paint. I go really thick on the clear coat just to make sure I mask all the little fuzzies that I can't get out. I'm not going to sit there with a Dremel and sand all the floors because there's just too much fine detail, too many small spaces to get in there and be effective. So I go ahead and take the surfaces that you'll actually handle, the black top surface, and I'll hit those with a little nylon brush afterwards, very, very lightly. I learned the hard way. If you go too hard with a nylon brush after this, you'll smear the black paint into the raw material areas. You'll have a lot harder of a time to get that fixed and look good for the customer. I just used some regular OB Clairlac side and matte, 10 bucks a can. It works really well in a pinch. Here you can see that I've got a pretty rough surface, but that's actually from the black paint underneath. But I went really thick on here. It's not dry, that's why it's glossy. And I've got some fuzzies. I can't tell if that's because I did this before the paint was fully dry, or maybe I need to swap to a new insert. And the final point of any job is to brand it. I've got my logo on here. I'll use a CO2 laser. It takes me about 40 seconds to run these out. And as I mentioned before, I learned the hard way that the brush will smear the black paint. So here's my recovery. I use a Dremel with a wire wheel, and if I happen to go over the V, I touch it up with a black paint pen. And that's pretty much it, everybody. So that's my entire workflow for making these wall crests. I hope you learned something. I hope this was of interest to you, and I will see you next time.